let's learn how to write out a net ionic equation and a total ionic equation from a molecular equation. So what we have right here is silver nitrate, and this is going to be reacting with magnesium iodide to yield silver iodide and magnesium nitrate. Now, this is a double replacement reaction, and this is going to form a precipitate. So notice how all of these two reactants are all my reactants, and this product right over here are aqueous, meaning that they are dissolved in water. Now, molecular equations basically are sort of like the most unrealistic, representation, or like not the most accurate kind of representation of what's going on with this reaction. And the reason why is because think about when you're dissolving salt in water. So if you have NaCl and you dissolve this in water, you're going to get the Na plus ion and the Cl minus ion, right? So the molecular equation basically just shows everything kind of intact, right? So imagine if we have like silver nitrate, right? If you dissolve that in water, it's going to disassociate into the silver ion and then the nitrate ion, right? But in the molecular equation, everything is sort of like intact, right? So sort of it doesn't actually represent what happens when an ion dissolves in water, right? So what we can actually do is we can write out a total ionic equation, which is basically kind of this equation right over here, except you're showing all the ions that kind of form from this. So, first off, what we have to do is we just have to balance this equation. So there's 2 nitrates on this side and only 1 on this side. So what I can do is I can put a 2 in front here. But now there's 2 silvers and there's only 1 silver on the product side, so I can put a 2 here. And it looks like we are done. We have, this matches up. Then 3s match up. Yep. All right. Now that this equation is balanced, we can write out the total ionic equation. So when this dissolves in water right over here, silver nitrate, we're going to get 2 Ag plus, and then this is going to be plus 2 NO3 minus, right? I'm going to have 2 of this ion and then 2 of this ion. And this is going to be plus Mg2 plus, and then 2 I minus, and this is going to yield. Our precipitate remains unchanged because remember that this is a solid, right? So it's not dissolved in water, meaning that it's going to stay intact. And then we're going to have the magnesium on this side, 2 plus, and then we're going to have the nitrate. So it's going to be 2 NO3 minus. Okay, and there we go. This is going to be the total ionic equation. This is our solid, and the rest of these are AQ, but I'm too lazy to write it out. All right, this is the total ionic equation. Now, the net ionic equation basically just tells you what actually reacts. So notice how when I write out the total ionic equations, there are some things that remain unchanged on both sides, right? So for example, look at this 2 NO3 minus here. And look at this. There's a 2 NO3 minus here on the other side. Look at this. There's an Mg2 plus on this side, and there's Mg2 plus on this side, right? These things are not reacting. These ions are not reacting, right? So these are something known as spectator ions. Spectator ions. And it kind of like is like the name, right? They're kind of just spectating. They're not really contributing to kind of the total reaction, right? And what we can do is we can write out the net ionic equation. So net ionic equation is just the total ionic equation, except you get rid of these spectator ions. So this right over here. So let me just do this. So the things that I'm marked in green are the spectator ions, and the things that I circled in white are the stuff that's actually happening. And if I write out the stuff that's actually happening, so 2 Ag plus 2 I minus yields 2 Gi solid. And then both these are AQ, like so. This is something known as the net ionic equation, right? This net ionic equation basically just tells us very specifically what's actually happening, all right? So the molecular equation is kind of like the least kind of, I guess, not really accurate, but like kind of like the least descriptive on what's actually happening. The total ionic equation is sort of like shows all of the ions, right? It's kind of like, if you dissolve all of these ions in water, right, they're obviously just going to disassociate into these ions, right? And then the net ionic equation basically just tells you kind of what's actually reacting, right? Because when all of this stuff dissolves in the water, not all of the ions are going to react. So your own for the net ionic equation, you're kind of just focusing on the only kind of important parts, the only stuff that's going to react.